Next topic here is unit 10, which is network layer in the internet. So you have the network layer kicking at the abstraction layer. You might have heard something like IP protocol, IP address, IP4 clustering. We have IPv6, so it could be shown somewhere here. So if I go here and I go to properties, then I see internet protocol version. Internet protocol version. If I go inside here, we have IP, DNS, alternative configuration, subnet mask, default gateway, preferred DNS, and everything. Let's understand those things here. So the congestion control, general principle of congestion control, traffic management, congestion prevention policies, quality of service, basic. The internet is considered of interconnection of subnet autonomous system. They operate at a layer, facilitate the subnet virtually connect to one another. The transport layer immediately above the network layer breaks data streams into data grams. The size of datagram has come 64 KB, but it is 500 KB so that they can connect to internet. So the IP protocol, to contrast the TCP, it is connectionless type service and operates third layer OCA reference model. That is, prior to transmission data, no logical connection is needed. The type of protocol is suited for sporadic transmission of data to number of days. Does not have such functions as sequence control, error recovery, control flow. So the IP datagram has a header of 20 byte size and a text variable of length. Header of the IP diagram depicts in 10.1. So IP is the internet protocol header, version, ISDL, type of service, total length, identification, DF, MF, frame set, time to live, protocol, source address, destination, and optimum. So data encapsulation adds the IP header to the IP header consists of 5 or 6 32-bit words. The sixth word is attributed to IP option with different IP header. Version refers to the version of IP protocol in use and keep tracks of version of protocol to which datagram belongs to. The current version of IP is 4. Internet header length indicates the length of the header is 32-bit words. The minimum length of the maximum value of this is 4-bit field and 15 that restricts the header to 60 bytes and thus options field to 45. Type of service enables the host to indicate the subnet of what kind of service reliability it wants. Total length is everything in diagram, max 64 KB. It is subtracted from the IHL field, indicates IP to the actual field of data length. The IP address. Using internet has become common. We'll now understand how internet interprets the internet address. The internet address can be written as hotmail.com for instance, more address. The is actual address, it is text version, it's actually the binary. Now we compare Hotmail, the server institution domain, WS and a server of your institution. The domain name is. Now the above case is simplifying the other institution my large enough like a web server, email server, print server. Suppose now we take example of the this has 5 parts of the server by 0. Now we have to understand this will indicate how place it go. So like this organization web server may create address for internet is a collection of several important networks which are interconnected with one another. Now each independent network may have host. Keeping in mind, you can now think of address of the house. The house is a unique house number which is not assigned to any other house. In case your house can be considered a host. The location is considered as a network in city domain. You can write your address. We already noted that host on it has 2 parts. These are identified of address of the host. IP4 addressing. Presently we use IP4 addressing. However, IP version is gradually under implementation. IP4 addressing are unique as network which works on network layer, identifies source and destination and packet. Presently the version of IP used is called IPv4. In this version, every node on internet may have one or more interfaces and we are required to identify each of these devices with a unique address assigned to them. It means that each node is one or more IP address to invoke TCP IP. Technically, IP addresses are expressing using binary notation 32-bit long string. In order to make these strings to remember easily, dotted decimal are used in which dots separate 4 decimal places 0 to 25, 32 bits and 32 bits therefore decimal places. For example, IP4 address this is expressed as 192, so this is the dotted decimal places. Now this represents IP4 conversion for binary notation. 32-book long address segment is 8 block. So IP address are expressed using binary which are 32 bits. So this is an IP address for 192.168.10.50. So the IP address in dotted decimal place 192.168.10 and 25. We have now seen as a 32-bit number in dotted IP addresses may have fixed part and a variable depending on the location of the addresses. Therefore, results into, for example, you have IP address that is 25. Now this is 25 bit. The classification of IP: unicast, multicast, broadcast. Unicast assigned to single network, local specific facilities, one-to-one communication. Subnet prefix, host ID. So subnet prefix is basically a network address portion of the IP. It should be noted that all nodes on the same physical layer logically must have the same subnet prefix, which eventually becomes unique for entire TCP/IP network. Host ID is the ID at which host portion of the IP identifies multiclass. It is used for one or more network interfaces. Location in various allows network communities to deliver single packet. Broadcast locates all network located in the subnet for one-to-one communication. Internet addresses are further classified into different cases. It is based on number of bits that are used for heading prefix. We have class A. It is an 8-bit network whose first bit always 0. Class B. It uses 16-bit for both of the network and host name. In this case, the first two bits are always 10. It is represented by IP unicast. It uses 2 octets for particular network while remaining octets host ID. They are particularly used for medium of large size network. The class B addressing can be provided to such a class C is for IP unicast address. This means for all this first 3 octets specified. And you have class D and class E. So class A, B, C, D, E, octet, 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 number of possible networks, maximum. So classification of IP4 address. So you have class A is a 8-bit network whose subnetting for IP address. So over the past several years, internet has scaled enormously volume in the terms of host, therefore IP4 address data available becomes scarce. You may have confusion between 32 bits and 2 unique, which comes around 4.3 different locations, but this is not the condition because different classes of IP address. Suppose a medium size class B addressed on current population of say 100, so 1000 address, but the organization managed the ability to assign to the power 16 different. This means that 65 address already recognized. Since they all belong to the same class B, they cannot be reclaimed by the organization. The network administrator may suggest that class C and which require at least 4 class C network. Later on, suppose number of increase in organization, other class C it may not get it may pass through the paperwork and delay. This is another in which regard many class C networks. So in order to implement subnetting, you need the following guideline: assessing the number of subnet required, assessing the number of IDs required. After this, a set of subnet addresses prefixed with a range of IP addresses are defined. Each number of host bits for the subnetting, determine the new subnetting, determine the range of IP addresses. Write down the number and prefix as a sum of 4 numbers. Then you have 198 class C network bit representation address range. So our example IP4 address is a 22-bit subnet mask. Congestion control. Congestion causes checking of communication channel. There are too many packets are present in part subnet or forward subnet case, and so communication channel of network is called congested if packets transfer with access of the path. This is heavily congested when packets never reach destination or infinity. Therefore, congestion not more means that different exceeds the capacity of output layers, the input part. So congestion control and flow control are two different phenomena. Congestion is global phenomenon including all hosts, all out except forward. General principle of congestion control: the open loop solution provides good design to ensure that problem does not occur in the first place. Designed to limit distance for itself. Closed loop solution make decision based on control of feedback loop. The feedback enables the closed loop to monitor the system when the congestion occurs. Congestion may be combined, be controlled as given below: increasing the bandwidth, split traffic to multiple load, increasing resources, decrease the load by denying service to some user or degrading service to some other estimating user. Then you have traffic management. Average traffic delay. Suppose traffic delay is lambda per second. Average processing rate is mu. Then utilization of channel is lambda plus mu. From Cohen theory, the above delay expected routing being forward is t upon mu. From the void is clear that average delay congestion prevention policy: data link layer, network layer, transport layer. So data issue with retransmission of packets, setting up. Then you have traffic shaping, leaky bucket. So incoming packet, outgoing packet, the token bucket algorithm. Then in the final topic here is quality of service. Quality determining the capability to provide predictable service over technique include frame delay, asynchronous transfer matter, ATM, Ethernet, IP. The network may be used for technologies. The QoS ensures that a flow may be combination of source to destination address, source and destination socket number. The traffic to computer network often receives equal priority, and the computer network usually do not differentiate between non-critical browser and is considered an important subject for internet. The amount of data transmitted via IP video conferencing like WSP. Basic QoS structure. QoS gives better services to certain flow in network by either raising the priority of a flow or delimiting the priority of another. The queue management tool, policy and shaping. Link efficiency tool and user controlling flow and congestion. The QoS tool. QoS concept: congestion management, queue management, link efficiency, eliminating overhead with traffic shaping policy. End-to-end QoS services. It was a very big chapter. So congestion, IP address, IP protocol and traffic shaping we looked at. So IP protocol are principal communication protocol used for laying data packets across networks using the internet protocol suite. IP address, internet protocol address, and a number assigned to each device, computer button, and internet protocol. So the details that we want to go ahead is the IP4 part, which we will look again.